So, hello, dear student. So, in this class, we are basically going to discuss AIT for chemistry paper, right? So, this is for NEET class, right? So, this is for class 12 NEET. So, in this, we are going to solve all the important questions. जिसमें सभी बच्चों को कुछ problems हुई हैं. So, we are going to solve all questions, right? So, let's start with the session. Okay, so the first question is what is the mole fraction of the solute in 1 molar aqueous solution, right? So this is a very simple question, right? You have to calculate the mole fraction of the solute in the 1 molar aqueous solution, right? So we all know one very important thing. क्या पता है हम सबको? We know that. What do you mean by this term 1 molar, right? So 1 molar basically means that is 1 mole dissolve in 1 mole in 1 kilogram solvent, right? 1 kilogram of solvent. This is the basic meaning of 1. Someone asked what is 1 molar. So 1 molar means 1 mole in 1 liter of the solution, and 1 molar means 1 mole in 1 kilogram of solvent, right? So let's calculate. You have to calculate the mole fraction. So we know that how to calculate the mole fraction of the solute. So for calculating the mole fraction of the solute, we use the formula, that is a number of mole of the solute upon number of mole of solute plus number of mole of solvent. So this formula we need to apply. So first of all, we need to calculate the number of moles, right? So for solute, it is already given 1 mole of solute is there. So calculate the number of mole of the solvent. So here, number of mole of the solvent, number of moles of solvent, right? So number of moles of solvent. So how will you calculate? We know that mole is nothing but mass upon molecular mass. So here the mass is 1000 gram, right? 1000 gram of the water, and the molecular mass of water is 18. So when you solve, it comes out to be 55.5, right? So this is the number of mole of the solvent. So just put the value here. So number of mole of solute is 1, and number of mole of solvent is nothing but 55.5. Right. So on solving, you'll get 0.0177. So which option is correct, beta? That is B. Option B. So option B is absolutely correct. So I hope सबने सही किया होगा इस क्वेश्चन को. बहुत easy question था and is basically based on the concentration defining term, right? चलो. Move to the next question. The next question is that is the gas equation PV is equal to NZRT become an ideal gas equation when Z is equal to what? So you have to calculate when this become ideal gas equation. So this is also a very simple question. We all know that what is ideal gas equation. So ideal gas equation is nothing but PV is equal to nRT, right? So when PV is equal to nRT, this is known as ideal gas equation. So when this Z is equal to 1, right? When this Z is equal to 1, this PV become nRT, huh? PV is equal to nRT and this become ideal. So compressibility factor, Z is compressibility factor. So whenever Z is equal to 1, because Z is the ratio of, Z is the ratio of the PV upon nRT, right? This is equal to PV upon nRT. So whenever the PV and Z is equal to 1, it means it is an ideal solution, right? So Z is equal to 1. Now, move to the next question. That is question number 3. That is, which of the following gas molecule has the highest mean free path? Okay, so you have to calculate the highest mean path. That is, which one of the following molecule has the longest mean free path, right? So it depends upon the very important term, like how will you calculate the use the formula, right? So we already know this thing, huh? Right. So we all know this thing very important, that is mean free path. That is mean free path. Yeah, we have to calculate this mean free path. So we know this question is from the states of matter. That is mean free path is inversely proportional to the molecular mass, right? This is inversely proportional to the molecular mass. So out of these four, which of the following, that is hydrogen, oxygen, N2 and Cl2, which having the minimum molecular mass? So obviously hydrogen. So the correct option is hydrogen, because hydrogen having the minimum molecular mass only one, right? So we can say that hydrogen molecule has the longest mean free path, right? Chalo, let's move to the next question. That is question number 4. ठीक है, question number 4 पे चलते हैं. What is this question number 4 basically? Hmm? So in question number 4, they are asking that is 1 liter of a gas collected at STP will occupy 2 atmospheric pressure at 27 degree Celsius, right? So 1 liter of a gas collected at STP will occupy at 2 atmospheric pressure and 27 degree Celsius. So you need to calculate the volume, right? That is 1 liter of gas collected at STP will occupy. कितना volume occupy वो करेगा? तो चलो देखते हैं फटाफट. So let us first write the given data. So we know at STP, we all know this thing. At STP, right? Standard temperature and pressure. What is this? That is P1 is already given. It is 1 atm. So P1 is 1 atm. Similarly, V1 is 1. V1 is 1 liter. And what is temperature beta? The temperature is 273 Kelvin. Now, what is the final condition? So P2 is given 2 atm in this question already given. Now V2 you need to calculate. V2 तो हमें निकालना है. And what is T2? So T2 is nothing but 273 plus 27 already given, right? So it's become 300 Kelvin. So you can use the general gas equation, right? So what is the general gas equation, beta? That is P1 V1 upon T1 is equal to P2 V2 upon T2, right? So P1 V1 upon T1 is equal to P2 V2 upon T2. So this is the general gas equation we have. So just put the value because we all know all the remaining values other than V2. So we can easily calculate the value of V2. So V2 comes out to be nothing but that is 300 divided by 2 into 273. Right. So this is the value of V2. So out of this, which option is correct, beta? That is 300 divided by 2 into 273. That is option B. So option B is absolutely correct for this. Right. So I hope समझ आ गया सबको. बहुत easy question था. चलो. Move to the next question. That is question number fifth. This is also from the states of matter and it's based upon the Graham law of diffusion, right? That is the rate of diffusion of SO2 and O2 are in the ratio. So you have to calculate the rate of diffusion of SO2 and O2. So we have SO2 and O2 and you have to calculate the rate of diffusion. So you need to calculate the rate of diffusion of both SO2 and O2, right? Let us calculate. So we know it's a very simple formula from the Graham's law that is rate of diffusion of SO2 divided by rate of diffusion of O2 is equal to under root of their molecular masses. That is the molecular weight of O2 divided by molecular weight of SO2. Right? So we all know this. What is the molecular weight of O2 beta? So we know this is equal to 32. Molecular weight of SO2 is nothing but 64. So it comes out to be 1 by 2. So the answer is ratio under root 1 by 2. ठीक है. So कितना आ गया? Under root 1 by 2. So this is the correct one. That is under root 1 by 2. So which of the following option is correct, beta? So the correct option is 1 under root 2, right? That is, yeah, A. So A is the correct answer. Okay? So A is the correct answer because we know that na under root of 1 is equal to 1, right? So this comes out to be 1 under root 2. So this is the correct answer. Clear है सबको? चलो. Again, the question is from the Graham's law of diffusion. So many questions were coming directly from the formula related questions, right? From the Graham's law. So this is according to this question, the value is given like if R1 and R2 are the rate of diffusion of two gases and D1 and D2 are their densities and M1 M2 are their molecular weight, then according to the Graham's law, so you need to establish the formula for this, right? So you need to establish the formula, that what formula you'll get, right? So we know this thing, that is R1 upon R2 rate is equal to under root D2 upon D1, right? So this formula we already know, that is R1 upon R2 is equal to D1 upon D2. So yeah, this one. And one formula we also know, that is R1 upon R2 is equal to under root of molecular weight of 2 upon molecular weight of 1. This formula we already know, right? So these two formula we know from the Graham's law. So according to this, which option is correct, beta? That is option number D. Option number D is absolutely correct. Right. Now move to the question number 7. That is if uncertainty in the position of an element is 0. right? If uncertainty in the position of an element is zero, the uncertainty in its momentum would be. So we all know this thing from the Heisenberg uncertainty principle. This is from the structure of atom chapter, right? So we all know this thing, that is delta P, hmm, into delta X is greater than equal to h upon 4 pi, right? Now, if someone says if delta X is 0, if uncertainty in the position is equal to 0, then what is basically, then delta P is equal to h upon 4 pi, and this becomes 0, right? So this whole quantity become infinity, right? So then delta P become infinity. So the correct one is D. Yani if the uncertainty, agar position mein uncertainty of the position of electron is 0, then uncertainty in the momentum would be definitely going to be infinite. Okay? So this is the correct one. Now, move to the question number 8, right? That is the number of unpaired electron in Fe2 plus. So this is very, very simple question, and this is from the D block, right? So, and in the structure of atom also, we study all these things. That is how to write the electronic configuration of this element and how to calculate the unpaired electron. So basically, we have a Fe plus 2, right? So we know this thing, Fe having atomic number of 26, right? So we can write like this will become 3d6 and 4 is 2, right? So Fe plus 2, for Fe plus 2, though 2 electrons are removed, then the remaining is 3d6, right? Then how will you fill this? We all know this, in d orbital we have a 5, right? In the subcell we have a 5 orbital, right? So just fill this like 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, and 6 electron. So the number of electron which is unpaired is nothing but n is equal to 4. So 4 electrons are unpaired, so correct answer is 4. Okay, so this is very, 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 very simple question. Now, move to the next question. That is the maximum wavelength of the radiation that can be ionized a sodium atom is 2414 Armstrong, the ionization energy of the sodium atom per molecule. So you have to calculate this energy. Huh? So we all know this thing, that is energy is equal to what? That is energy because we have N, H and mu, right? And we all know this thing, we can write N, H and mu is equal to C upon lambda, right? Mu is equal to nothing but C upon lambda, right? So this mu comes out to be C upon lambda. So now you know the maximum wavelength radiation that can be ionized a sodium atom of this, the ionization energy of sodium per mole, right? So for per mole, for the one, right? So you can use the formula H, we already know, that is nothing but 6.67 into 10 raised to the power minus 34. C we already know, that is 3 into 10 ki power 8, and lambda is given, that is 2414 Armstrong, that is 10 raised to the power minus 10. So on solving this question, you will get the value of E, right? So you'll get the value of E. So E comes out to be 497.7, and the unit is kilojoule per mole, right? Kilojoule per mole. Here you can confuse between these two quantity B and D, but the correct one is kilojoule per mole, not joule per mole, right? So not this one. This is the correct one. Okay. Chalo. So this is how you can actually solve this question. Now let's move to the next question. That is question number 11, right? Right. So the correct order of the bond order will be, so you need to calculate the correct order of the bond order, right? So चलो देखते हैं कैसे निकालोगे bond order का correct order जो है. So we all know this thing. It's a very important, that is a trick we also share with you all, right? This is how to calculate the bond order, right? So let me discuss this trick again, right? So that you can able to calculate bond order of the any particular molecule. The rule is, or we say trick, that is here we have a electron sum, and here we have bond order, right? So if the electron sum is 10, 11, 12, 13, 14, 15, 16, 17, and 18, bond order would be 1, 1.5, 2, 2.5, 3, 2.5, 2, 1.5, and 1. So this is the trick that we are going to use for calculation of bond order, right? So here in case of NO plus, let me explain with this. We have a NO plus, we have NO negative, and we have NO, right? So NO plus, the electron sum in NO plus is N, we have N having the 7 electron and oxygen having the 8 electrons. So 7 plus 8 and minus 1, because we have a plus 1 charge. So this is 14, right? This is 14. Here we also have 7 plus 8 plus 1, that is 16, right? That is 16. Here we have 7 plus 8, okay? That is 15. So according to this rule, 40, if the electron sum is 14, then the bond order is 3, right? Bond order is 3 maximum. So NO plus having the maximum bond order. The order is NO plus. Then in 16 corresponding to 2 and 15 corresponding to 2.5. Then comes NO, and then comes NO negative, right? So this is the correct order. That is NO plus, then NO, and then NO negative. So which of the following? That is option B. So this trick is always help you. Okay, this is a very simple and this trick is always helpful for calculating the bond order, right? Whenever you have to calculate the bond order, and by using this rule, you can calculate bond order within second only, right? Just remember this rule. So this is very helpful for calculating the bond order, right? Now, move to the next one. That is question number 12. That is the formula of the metallic oxide is MO, right? The formula of the metallic oxide is MO. The formula of its phosphate would be. So, if the formula of the metallic oxide is MO, then you have to calculate the formula of this, right? So, metallic oxide is MO. What do you mean by this thing? Metallic oxide, formula of metallic oxide is MO. So MO means what? We all know oxygen having minus 2 charge. So this having plus 2 charge. So this is very much clear that metal having plus 2 charge. So write it here, right? And again, phosphate, we all know this phosphate. The formula of phosphate. So phosphate, yani PO4. So we all know PO4 having the 3 charge, right? Phosphate having the minus 3 charge. So formula is like M3, and this is PO4 twice. So this is the formula, that is M3PO4 twice. M3PO4 twice. M3PO4 twice. Yeah. So the correct option is yeah, that is option A. M3PO4 twice. So this is again is very simple question, right? This is again a very simple question. ठीक है? समझ आया सबको, I guess? हाँ? Sure. Very good. Now move to the next question. That is question number 13. So among LiCl, BCl2, BCl3, and CCl4, the covalent and the covalent bond character follows the order. So you have to calculate the covalent, right? So we know this thing, that is the covalent character depends upon the electronegativity, right? So if you move from Li, then Be, then comes boron family, then comes carbon family. This is the group 1, group 2, group 13, and group 14. So as you move from left to right, the covalent character tendency will increase. So maximum covalent character will be shown by CCl4, right? Then comes BCl3, BCl2, and LiCl4, right? So this is the correct. This is a very simple question. Okay? Chalo. Move to the question number 14. That is the bond angle and the percentage of D character in SF6. So we all know this thing, SF6 having octahedral structure. So let me draw the structure of SF6 as well. So this is the structure. This is SF, this one, chicken, and this is again SF. So this is the structure of SF6, right? So they are asking in SF6 percentage D character. So the hybridization of SF6 is the SF6 hybridization is number of sigma bond they form 1, 2, 3, 4, 5, 6, right? 6 plus 0 lone pair. So 6 means sp3 D2, right? So 3 to 5 and 6, sp3d2. Now they are asking percentage of percentage D character. So we know that total we have a 3 to 5, 6. So 100 divided by 6, right? 100 divided by 6. So it comes out to be 6 ones are 6, 4, 0, 6 6 are 36 again. Yeah, 16.6. So 16.6 into 2, because D having 2 na. So 16.6 into 2. So around 33 percentage, right? So 33 percentage, and bond angle will be 90 degrees. So each one having bond angle of 90 degrees. Okay. So the correct option is B. That is bond angle is 90 degree and the percentage D character is 33. Okay. Percentage D character is 33. So I hope this is clear. Okay. Sure. So this is how you can actually calculate this value. Now, move to the next question. That is the fraction of the total volume occupied by the atoms present in the simple cubic unit cells. Okay. So you have to calculate the fraction, the fraction of the total volume occupied by the atom present in the simple cube. Right. So we all know this thing. In case of simple cubic cell, the packing efficiency is what? We know that in SCC, the packing efficiency is 52.04%. In BCC, the packing efficiency is 68%. In FCC, the packing efficiency is 74%, right? So we know this thing. So the correct answer for the packing efficiency atom present in the simple cubic is 5 by 6, right? So this is a no memory based question. We all know, we all remember this thing. In case of SCC, the value is like this. Okay, right? Chalo. Now, the next question is, you need to calculate the conjugate base of ammonia ion, right? So you need to calculate the conjugate base of ammonia ion. Okay. So we know this thing, ammonia ion they are asking, that is NH3 plus. So conjugate base of ammonia. If they are asking conjugate base, it means they are acid. So we all know this acid having tendency to lose electron. So if they tendency to lose electron, or we can say they have a tendency to donate H plus. According to the Bronsted-Lowry concept, they have a acid having tendency to lose electron, and they're asking conjugate base of ammonia. So if they are asking conjugate base of ammonia, then assume this is behave as a acid right now. So acid having tendency to lose electrons. So this will become NH2, right? NH2. Now again, conjugate base of ammonia they are asking. So we know this thing, it's a very important thing, that is a conjugate acid is formed. When the conjugate acid is formed, okay? So because they are asking conjugate base of ammonia ion, but you need to calculate both these things, right? Because in some questions they are also asking the conjugate acid of ammonia. So first of all, you need to know what do you mean by this term, conjugate base of ammonia, conjugate acid of ammonia. So conjugate acid is formed when the proton is accepted by the Bronsted base. So whenever the proton is accepted by the Bronsted base, then conjugate acid is formed. While the conjugate base is formed when a proton is donated by the Bronsted acid. Yani when the Bronsted acid is donated a proton, then conjugated base is formed. Okay, so this thing you need to remember. Now let's see. For example, we have NH3, right? We have NH3. So when they react with the H2, they will form NH4, NH4 plus and OH negative, right? So this is the conjugate base and acid pair, right? Similarly, NH4 plus and NH3 are the conjugate acid and conjugate base. H2 and OH negative are the conjugate base and the conjugate acid for both. Right. So in this question, they're asking the conjugate base of ammonia ion. So conjugate base of ammonia ion is ammonia. Okay. So conjugate base of ammonia ion is nothing but ammonia. So which option is correct? That is B. So option B is absolutely correct. ठीक है. So I guess सबको समझ आ गया होगा कि why how option B is correct. Sure. Now, move to the next one, that is question number 70. That is the four species are listed below. That is HCO3 negative, H3O plus, and HSO4 negative, and we have HSO3F. So, which one of the following is the correct sequence of their acidic strength, right? So, you have to calculate which one of the following is the correct sequence of their acidic strength. So, we have SCO3 negative with us, S3O plus we have, right? And we have HSO4 negative as well. HSO4 negative as well. So always remember, acidic nature depend directly proportional to the more negative charge, right? So this is a factor that is acidic nature. So acidic nature is directly proportional. ठीक है? Acidic nature is directly proportional to the more negative charge. More, let me write again. Yeah, that is more negative charge. ठीक है. So acidic nature is directly proportional to the more negative charge. So out of this HCO3 negative, they having one negative charge, they having positive charge, and SHO3F, right? So which having the maximum negative charge. So all we know fluorine is the most electronegative element, right? So the correct order is like H3O plus, then comes HSO4 negative, then after HCO3 negative, and last HSO3F, right? So this is the correct order, right? So the maximum one is fourth. So which option? There, fourth. And the next HCO3. After fourth, we have one, then three, HSO4, and then two, right? So option A is absolutely correct. Okay. Now, move to the next question. That is, which of the following is an acidic salt? So we have to calculate which of the following is an acidic salt. We have a two option like Na2S, NaHS, Na2CO3, Na2SO4. So always remember, acidic salt means what? Basically, salt is formed when the acid and base react. So whenever the strong acid with the weak base, it will form acidic salt. Whenever a strong base with the weak acid, they will form basic salt. So you have to calculate out of this which is the acidic salt and which is not. So Na2SO4 is the strong acid, strong base salt, so it is a neutral, Na2SO4, right? So isko to gap karo. Now the next is NaHSO3 is an acidic salt. Why NaHSO3? And the next is HS, right? NaHS, Na2S. So Na2S is a weak acid. So this is also not true. Next is Na2SO3. So Na2SO3 is a weak acid again. So this is also not true. This is a strong acid and a strong base. So only option we have NaHS, because in NaHS they are formed by the strong acid, right? Strong acid and the weak base. So we can say that this is a acidic salt. Now, move to the question number 19. So this question is from the equilibrium chapter, that is given HF plus H2. When the HF react with H2 in the K, they will give H3O plus F negative. Similarly, F negative accept H2O, KB, HF plus OH. Which of the following relation is correct? So you have to calculate the correct relation. So when the above the two reaction are added, the next reaction is when you have to add. This is equation number 1, suppose, and this is equation number 2. And now you want to add this equation. So what you get beta? H2 and H2O. So this will become 2H2O. Hmm? And this F negative and F negative will cancel out each other. This HF and HF cancel out each other. So you are left with 2H2O KW. This will gives us H3O plus, and this is OH negative. So if you want to calculate K for this, K comes out to be concentration of H3O plus, then F negative divided by HF and then H2. Okay, HF and H2. So this is the Ka. Similarly, if you want to calculate Kb, what is Kb comes out to be beta? Kb comes out to be HF. Okay. Here from this two equation, that's the equation 1 and 2, I'm calculating K and Kb, right? So Kb comes out to be HF and OH negative. ठीक है, ये देखो यहाँ पे ध्यान से, यहाँ से कैलकुलेट कर रहा हूँ. HF OH negative divided by F negative and H2. Right. So this is Kb. So when you multiply this Ka and Kb, you will get Ka and Kb is comes out to be nothing but H3O plus multiply by OH negative, which is also known as Kw. That is ionic product of water. ठीक है. So K into Kb is equal to Kw. So K into Kb is equal to Kw. Which option is correct? That is option number C. So option C is absolutely correct for this. Now, move to the next question. That is the compound insoluble in acetic acid. So you need to find the compound which is insoluble in the acetic acid. So always remember, calcium oxalate is insoluble. Calcium oxalate, this one, right? So calcium oxalate is insoluble in acetic acid, right? Where the calcium carbonate, calcium oxide, and calcium hydroxide, they are soluble in the acetic acid. So which of the following is the correct beta? The compound which is insoluble, that is calcium oxalate. चलो, now move to the question number 24, right? So 24 क्वेश्चन पे चलते हैं कि क्या है ये 24 क्वेश्चन. That is the osmotic pressure of the 5% solution of cane sugar, right? So you need to calculate the osmotic pressure of the 5% solution of the cane sugar at 15 degrees Celsius. So you need to calculate the osmotic pressure only. So you all know this thing, osmotic pressure having the formula CRT, and we can write C as N upon V into R into T, right? N upon V into R into T. Now, what is this N upon V into R into T? So here N is 0. Yeah, because N is mass upon molecular mass. So we can also write as mass divided by molecular mass into RT upon V, right? So here, what is the mass? So mass 5%, right? So 5% we know mass is 5% only. So mass of the solution is 100 gram here. So we can calculate mass 5% solution means 5 gram in 100 gram. So mass is 5 gram. Molar mass or the of cane sugar is already given, that is 342. R values, we all know this thing, the value of R, right? It is 0.082, that is 0.08206, and the temperature is 288, and the volume is also given. The volume is nothing but 5% solution means 5 gram in 100 gram, right? That is a 100 mass of the solution is 100 gram, and density is also given. So if the density is, let us assume density is 1 gram per mole, then the volume comes out to be 0.1 liter. So just put this value. So on putting this value, you'll get the desired equation is 3.45 atm, right? So out of these, yeah, option B is absolutely correct. ठीक है. Sure. Now move to the question number 25. That is at 25 degrees Celsius, the highest osmotic pressure is exhibited by 0.1 molar solution of what? So highest osmotic pressure, right? So osmotic pressure, we all know this thing. This also depend upon the Ventov factor. That is pi is equal to CRT into I. So if the I value, that is Ventov factor, is more, then the obviously osmotic pressure is also more. So this is a covalent compound. So this will doesn't dissociate or associate. So out of KCl and CaCl2, so CaCl2, they will dissociate to give two ions, right? One Ca and two chlorine. So number of ion is 3 here. So obviously this will giving the maximum osmotic pressure, right? Now, the next is a statement-based question. That is the relationship which describe variation of the vapor pressure with the temperature. So the relationship which describe the variation of vapor pressure with the temperature is nothing but Clausius-Clapeyron equation. So let me write this equation as well. Clausius-Clapeyron equation. So according to the Clausius-Clapeyron equation, that is log P2 upon P1 is nothing but is equal to delta HV vapor pressure upon 2.303 R, and this is nothing but T2 minus T1 divided by T2 into T1. So this is the equation, right, which describes the relationship between vapor pressure with the temperature, the Clausius-Clapeyron equation. ठीक है, fine. So I hope this is very simple. Again, question number, that is question number 27. This is very easy question, right? You all able to solve this question. This is a very easy question. So what the question asks basically, that is the unit of mole fraction. So you need to calculate the unit of mole fraction. So what is the unit of mole fraction? So it's a very simple thing. Mole fraction is nothing but is equal to number of mole upon number of mole plus number of mole. So it is a unit, it is a dimensionless quantity because it is a ratio of the two same quantity. That is the number of mole upon number of mole. That's why this is a dimensionless quantity. Okay. Now move to the next question. That is 1 mole of solute A is dissolved in the given volume of a solvent. The association of the solute takes place according to the Van der Waals expression, right? So we all know this thing. This is a very simple thing to understand, right? And what is this beta? That is, we know this thing. I is equal to 1 plus n minus 1 into alpha. This is for dissociation. Dissociation. And for association, I is equal to nothing but 1 plus 1 upon n minus 1 times of alpha. So we can write alpha, right? So this is I is equal to 1 plus, right? So we can also write as I is equal to, hmm, This one. That is 1 minus x upon n plus 1. So this is how we can actually write this thing. Clear? How to write? Done? So this is how you are able to write such thing. Okay? Chalo. So the correct option is that is C. Now move to the next thing. That is क्वेश्चन नंबर 32. ठीक है, तो क्वेश्चन नंबर 32 क्या कह रहा है हमसे, फटाफट देख लो एक बार. अकॉर्डिंग टू क्वेश्चन नंबर 32, फॉर द सेल द फॉलोइंग रिलेशन होल्ड्स, दैट इज डेल्टा जी इज इक्वल टू माइनस आर टी एल एन के. डेल्टा जी इज इक्वल टू 2.303. Delta is equal to 2.303 into this, or we say E cell is equal to 0.0591 log K at 25 degrees Celsius, and E cell is equal to 0.029 log K at 25 degrees Celsius. So you need to, for this cell, you need to calculate this thing, right? That is delta, what is the relationship that holds true for this reaction? Okay? Right. So the following relation holds true is delta G is equal to minus RT ln K. So this is the correct one. Now, in the question number 33, they're asking, given delta M naught HCl for this is 426, NaCl 126, CS3CuNA 90. Calculate the value of the acetic acid. So you have to calculate the molar conductivity, limiting molar conductivity of CH3COOH, right? So how will you calculate this for, right? So we know we have a three value for HCl and for NaCl and for the CH3CON. So we can calculate the CH3COH by just adding the value of, that is HCl, hmm, HCl plus CH3COONA, this one, and subtract the value like NaCl, right? Because we need to want CH3COH only, and this NaCl will be cancel out each other. So just put the value like 426 plus CH3CONA we have a 90 and minus 126. So value comes out to be around 390. Okay. So which option is correct, beta? That is option number D. Now, move to the next question, that is question number 35. That is the equilibrium constant for the equilibrium SO plus half O2 is SO3, and 2SO3 gives us 2SO2 plus O2 are K1 and K2 respectively. You have to establish the relationship between K1 and K2. Okay, what is the relationship between K1 and K2? So we can write K1 as nothing but concentration of SO3 divided by concentration of SO2 and O2 raised to the power 1 by 2. ठीक है, raised to the power 1 by 2. Here also we have a K2. So how will you write the expression for K2, beta? So write the expression for K2 as this is equal to SO2 raised to the power 2. This is O2 divided by SO3 2. Right. So we can easily see the relationship between K1 and K2. That is K2 is nothing but 1 upon K1 square. ठीक है, so K2 is 1 upon K1 square, right? So option D is absolutely correct. चलो, now move to the next question, that is question number 36. That is the standard gibbs free energy change delta G is related to the equilibrium constant. So how this will related to the equilibrium constant, how we can write as, that is it's a very simple thing, we all know this thing, that is delta G is equal to delta G naught plus RT ln Kp. So at equilibrium, when the delta G is equal to 0. So when the delta G is equal to 0, this will become, that is ln Kp is equal to minus delta G naught divided by RT. So we can write now Kp comes out to be E raised to the power minus delta G naught divided by RT. So which option is correct, beta? That is option number D. Done? Now, move to the next question, that is question number 37. What is the ratio of Kp by Kc for this reaction? So you need to calculate the ratio of Kp by Kc for this reaction. So we all know that there is a relation between Kp and Kc, that is Kp is equal to nothing but Kc RT to the power delta Ng. So you need to calculate delta Ng for this equation. So what is delta Ng? Product side gaseous mole, that is 1, minus reactant side, that is 1, and how that is zero point 0.5, that is 3 by 2. Okay. So 1 minus 1.5 minus 1.2. Okay. So this comes out to be minus 1 by 2. Done. Now, this is delta Ng. So you have to calculate Kp by Kc. So how will you calculate the Kp by Kc by? So Kp by Kc comes out to be, this is Kp divided by Kc. This equal comes out to be RT, and this is minus 1 by 2. So we can say that Kp by Kc is equal to 1 upon under root RT. Huh? So yeah, option C. So option C is absolutely correct for this. Now, move to the next question. That is question number 39. Okay. So what is question number 39 basically? Right. So in this question, you have to calculate that is the plot that represent the zero order reaction. So you all know this for the zero order reaction, the plot is like this, right? We already done this during the integrated rate equation. The plot for the zero order equation is like this. Here we have a concentration of R and in this T, and the slope is minus M, right? So this is the curve for the zero order, right? So this is the correct one. So which option is correct, beta? That is option number A. And LNR, this is for the first order. This is for the first order. ठीक है, चलो. Okay, so now move to the question number 41, right? What the question number 41 basically asks, that is according to this question, which of the following expression is correct for the first order reaction? C naught refers to the initial concentration and T half refers to the half lifetime. So you have to establish the relationship between the T half lifetime and the initial concentration of this reaction. Okay, so we know this the very simple relation between the T half and the initial concentration is, that is T half is directly proportional to C naught, that is the initial concentration, raised to the power 1 minus N. So here in this we have first order. So the first order N value is 1. So this T half is directly proportional to C naught raised to the power 0. Right. So which option is correct, beta? That is option E. Hmm? Chalo. Move to the next question. That is the increasing order of the pKa value. So in this they are asking pKa value. Always remember this pKa value is inversely proportional to the Ka value. Right. Ka means which is highly acidic in nature. Acidic. So in this you need to calculate the more basic thing, right? So we know this whenever the electron withdrawing group is attached like NO2, they always increase the acidity. So and the in para position they are dominating. So this is the more acidic. So B having if I arrange according to the K value, acidic value, then B is the maximum, then comes C, then comes A, and here we have an electron donating group. So this is the least acidic, and then come D. So this is according to the Ka value. But in this question, they are asking me to calculate, right? In this question, they are asking me to calculate the according to the pK value. So just reverse the order. So pKa value is like D is maximum, then A, then C, and minimum is B. So which option is correct, beta? That is D, then A, then C. D, A, C, and B. Yeah, that is option number D. Is absolutely correct. Chalo. Move to the next one. That is the order of reactivity of the following alkyl halide for the SN2 reaction. So whether you are talking about SN1 or SN2, right? The alkyl halide reactivity is always Ri, then RBr, then RCl, and then RF. This is for SN1 and SN2 both, because as the size of the alkyl halide is more, they easily break, right? So correct one is this one. Now, move to the next last two question. So we have question number 49, right? So in question number 49, they are asking basically for the reaction K1B and B K2C. If the rate formation of B is set up to be 0, then the concentration of B is given by. So you need to calculate the concentration of B. That is, what is the concentration of B? This is from the chemical kinetics as well. So we know this according to the question, that is dV by dt, that is the dV by dt is equal to 0, right? So we can calculate as, that is K1A minus K2B, right? So and this is equal to 0. So you need to calculate K2B. So K2B is equal to K1A, huh? So now you need to calculate only B. So B comes out to be K1 divided by K2 into concentration of A. So yeah, option D is correct one. Again, this question that is increasing order of the boiling point. So boiling point basically depend upon various factors. So in this we are going to do this question by seeing is dipole moment. So this boiling point is directly proportional to the dipole moment, right? Dipole moment, right? So this BP is directly proportional to the dipole moment. So out of this, we know this the dipole moment of which of the following having the maximum dipole moment, beta. So we know this thing that is the dipole moment is maximum for this NO2. So this NO2. So NO2 having that, let me write this value as well. So NO2 having a dipole moment of 279. Again, this NH2 having 284. This data is from the NCRT itself, 284. And 243 for OCS3. This is 243. And this is 202. Right, 202. So you can arrange according to this. So maximum we have that is NH2. Right, maximum we have NH2. So the value is like 284, 279. So the third one that is maximum is 3, 2, and 1 and fourth, right? Um, Let me write again, right? So the maximum value is for the, you can arrange according to this. So the boiling point is correct order is 1 we have CS3, 2 we have NO2, third we have NH2 and OCH3. So the correct order is 1, then 4, then third, and then 2. So this is the correct one. Okay. So this is how you can actually solve this question. So this is we already cover all this question in this chapter, important questions. So we cover all the important question in this session, right? So try to solve question by your own. एक बार तुम लोग को try करो solve करने का, एक बार देखो जिस जिस पे problem आ रहा था, and try to cover it. ठीक है? So in the next video we are going to see more things, right? So till in this you can just look at this doubts और जिसमें जिसमें भी डाउट था उसको एक बार कवर कर सकते हो, ठीक है? So this is all for the today class. Thank you all.